So now we want to look at the automatic failover. In the previous video, we tested the manual failover, and we see the different ways and method we can do the manual failover. But in this video, we want to also test the automatic failover. So if I do show chassis cluster status here, you see that we are back to how it was in the beginning, when node 0 was the primary for both redundancy group 1 and redundancy group 0. So the question is, remember, we are still doing a continuous ping to the internet. It's still working. And so what we want to do now is, on the primary device, which is this topology, we want to power cycle node 0. Okay? So we're going to do a power cycle of this device. And the expectation is that the secondary is going to see that the primary is lost. Okay? It's going to say primary is lost for both redundancy group 1 and 0. And then we expect this traffic to move from, instead of going through the node 0, it starts going through the node 1. Okay? So that is the expectation for the two IPs, the two servers. Okay? And then we're going to see when it comes back up, right? Will he automatically take back that row as primary? Because currently he's primary for both redundancy group 0 and redundancy group 1. Okay? When it goes down and comes back up, is it going to automatically take back those row? Okay? So that's what we need to figure out now. So I'm going to bring back my topology. Yeah. So I don't think so. In this, what the point I'm trying to make here is this. Now remember we talked about preempt. Okay. We all know preempt as network engineers. We know what preempt does. Now at this situation, we don't have preempt configured. No preempt. Okay. Okay. So we are testing automatic failover, right, where there is no preempt. Okay, let me be sure. Let's quickly check the configs again. I don't know if I made some changes, so I'm just going to say show configuration. Let's just say match preempt. I don't think it's configured. Oh, there's preempt, so I need to take it out. It's probably due to my testing. Yeah, so I need to take this preempt out. I just noticed that now, because what we really want to test is where there's no preempt. So I'm going to delete that, commit and quit. Okay, so now there's no preempt configured. Okay, now so we're going to see the behavior when we do a power cycle of the primary device, which is currently the primary for both redundancy group 0 and redundancy group 1. Okay, so just to check again. Yeah, so it's still the primary. So I'm going to say request system, I think it's reboot. Yeah, so we're going to hit the reboot. So before we do that, let me be sure that I've logged into this device. So I'm going to say root. Okay. So we can also do it. Show chassis cluster status. Should be the same output. So as you can see here, it's the same output with the primary. So on the primary, I'm just going to hit yes now. Okay. So at the moment we initiate the reboot, let's see what changes here. Now you see that within 3 seconds, okay? Within 3 seconds, we see that node 0 is now reported as lost. Okay? Remember, this is because of the heartbeat. Okay? Remember, every heartbeat is sent every 1000 milliseconds. Okay? Right? And the threshold is what? 3 intervals, okay? Which amount to 3 seconds. So if it does not receive heartbeat from both the primary, okay, we've said this before, but let me just go over it again. What we said that you have the EM0 as the control link, and let's say this is our fabric link. Okay, we said that what we said was that the heartbeat is sent across the control link, right? Now the moment it doesn't get those heartbeats, right, it's going to move into a state, right, called the ineligible state. Okay, it's first of all going to go into the ineligible state. Okay, now it's going to try to test, can I send heartbeat through the fabric link? If it's in the fabric link, then it moves into the disabled state. Okay, but in this case, both the fabric link and the control link were completely out. That's why it says here they are lost. Okay, so there's no point going through eligible to disable. It transitions straight to what? To primary, because it means something is obviously wrong with the weather node 0 device. Okay, so we're just going to wait and see what happens when that device comes back up. Let me clean this. So if I do show chassis, so it's still going to be lost. This could take a while, could take up to about 5 minutes. So I'm just going to pause the video a little bit, and when as soon as it's very close to coming up, we are going to continue and see what happens. Okay, the reboot is completed, so I want to do a login now. So I'm just going to say root, here's my username. Right, so let's say show chassis cluster status. Okay, so it's going to go through the hold period. Okay, this is not, I don't think this is related to the hold down time. I think this is just related to what happens when a device comes back up. I think they're trying to sync with each other, and then it's going to be secondary first. So you see, it puts itself as, so it automatically sets its priority to node 0 because it only detected there's already a primary. Okay, so it set itself as the priority as 0, is secondary, which is the node 0, and put itself as the secondary. And something we forgot to do was to look at if there was a packet drop. We just when we did the power cycle, probably we'll do it again. I don't know. We could have checked if there was a impact, but of course from what we see here is not, we would not be able to detect if there was any traffic impact. Of course, maybe you should have like 1 or 2 or 3 packet drops as the traffic moved from the node 0 to node 1. But I think our focus here is to see what is really going to happen with this state, right? Is node 0 going to take back its role or not? Now what we know is this. This is our node 0 and this is our node 1, right? This is node 0, this is node 1. If you don't enable preempt and this device power cycle or goes down and then comes back up, right? Now when it goes down, this takes up the primary role, right? For both ROG0 and redundancy group 1. Okay, when this device comes back up, if preempt is not enabled, okay, if preempt is not enabled, this device will not preempt the secondary node 1. Okay, so what end up happening is that for this device we become secondary for both redundancy group 0 and also secondary for redundancy group 1. Okay, it will not preempt because here no preempt was enabled. Now preempt is not supported in redundancy group 0. Okay, not supported. You cannot preempt redundancy group 0. If you try to configure it, it will act as if it's taking the config, but when you try to commit, it's going to say bam, you can't configure preempt in redundancy group 0. So in 100% of the time, you're always going to be doing manual failover of the routing engine, which is redundancy group 0. Or like what we just did now, we did a power cycle, so it automatically moved. Okay, now for redundancy group 1, if preempt is not enabled, he will now retain the secondary role. The traffic will not move back automatically. But when preempt is enabled, right, then they are going to compare their priorities and then say, oh, I'm 200, we know here is 200, we know here is 100, right? So he's going to preempt the primary role and then it comes back up. So what we're going to do is we're going to see when the whole process is back online, we're going to see, okay, what is the status now? And then we are going to go back again and then we'll do the second reload again, okay? And then no, so we'll configure preempt and then we do the second reload again and see what the result will be like. Okay, so I'm going to come here now. I say show chassis cluster, just to the upper key. So as you can see, this value has been updated now. Remember, it was 0, initially 0. Okay, I'm not sure if the hold down timer is also responsible for this. Okay, I'm not sure. I didn't read it anywhere on how long it takes for it to, you know, change this value from 0 to 255. Of course, we already agree it's because it's seeing node 1 as the primary for the redundancy group. So it's first of all put itself at node 0, trying to get all his processes running, you know. So, and then you see the value has been set. But for redundancy group 1, you see it's still not updated. So let's do it again. Still not updated, so we need to wait. Now, you also need to take a look at these flags that you have here, which is CS. Okay, CS means there's a code sync monitoring. Okay, sometimes you see config sync monitoring. Sometimes you see IF. Where is IF? Interface monitoring. Probably when we enable interface monitoring, we're going to see this flag as well. But currently it's saying there's a code sync monitoring. So it means there's still something going on between both devices, you know. I'm going to look up what this code sync monitoring actually means or what it does, but that is what it's telling us here. So it's still no 0. So I'm going to just pause the video again until everything stabilizes. So as we can see here, the system is fully converged and the priority values are back to what it was. But what we noticed was that node 0 did not automatically take back its role. Okay, and here is really what happens. I think I've already explained it. Okay, node 0, because preempt is not even allowed, if there's a power cycle and the primary move to node 1, it's going to stay there. Okay, there's no preempt, or except you do a manual switchover. Okay, you can manually move it back to the primary, but on its own it will not come back to the primary, which in this case is node 0. But what we can do now is on redundancy group 1, we're going to enable preempt. Okay, we're going to set preempt, and then we'll see what happens when the primary goes down again, and then we will see that because preempt is enabled, okay, in redundancy group 1, it's going to take back that role. So we can either power cycle or we can just shut the I think it's, in this case, I prefer to do a power cycle. Okay, so I'm going to say set chassis cluster redundancy group 1. I'm going to say preempt. Okay, now under preempt, remember what we talked about in the previous videos? You have different options here. You have the delay, you have the limit, you have the period, right? Now the delay, limit, and then period. Now delay, this applies to the secondary, okay, device. You are saying how long should the secondary wait before it transition, okay, before it transition from the secondary down to the primary. Okay, how long should it wait? Or the reverse. Now the limit is how many failovers are allowed. Okay, now you can set a limit to say 3 failovers within 300 seconds. Okay, so if you have more than 3 failovers in this interval, right? Now this interval applies is the period. Okay, if you have 3 failovers within 300 seconds, then you are going to disable preempt. It's going to automatically disable preempt until you manually reset the count again. Okay, so that's what these values are. So if you don't set it, I think they just take the default values, right? I think this is between 1 seconds to 21,600 seconds. I think this is between 1 seconds to 1440 seconds. Okay. I'm going to see if there's a way we can actually test this where we can do failover. I think we'll do it maybe probably in the next video where when we are doing interface monitoring, or maybe in this video if there's still enough time. And then we're going to like shut the port down, shut it down, bring it up, shut it down, such that you have a count that is higher than so that we are able to hit this value within 5 minutes. Okay. And you see what happens, that it will get to a point that preempt automatically gets disabled. Okay, so we are going to try that now. So let's go back and enable preempt. So I'm going to say preempt, and then I hit down, then we can set the delay. Okay, so I'm going to say when you see the primary is okay, it's even explained here, right? See what it says. It says time. It says time to wait before taking over the mastership. So this applies to the secondary device. Okay. On the primary, there's a port flap that maybe the weight of the port is 255, right? It takes the threshold down to 0. So there's a failover to the secondary. How long should the secondary wait before it takes up the primary role? That is what this delay is saying. Okay, so you could have a situation whereby the port is going up, down, going up, down, going up, down, right? You don't just want to take back that row. You want to what? Wait. Okay, maybe the port is down for 30 seconds, then in the next 30 seconds it's back up. Okay, now I know you might think, well, if the port is slapping, why not just move the traffic away? It also applies to the other side, that if the traffic moves to the secondary or node 1, right, and on node 0 the port keep flapping, right, this will give us some level of stability between both devices. Let me see if I can explain it better here. So let's say, for example, you have this two device. So you have this port, right, that goes to your LAN, which is what we have. I could have just used the diagram. So there's this port goes down, right? Threshold goes from 255 to what? 0. So there's a switch over. So in this case now, of course, we are referring to redundancy group 1. Okay? There's a switch over to the secondary. This is node 1. This is node 0. Okay? So this port goes down. How long should this device wait before transitioning from node from secondary down to the primary? Okay, that's the question. That's what this delay is saying here. So we are going to just set a value of I think we can just say 60 seconds. So I'm just going to say it should be 60 seconds. Okay, and then we're also going to say for the count or the limit, we're going to set it to, we're just going to say when you have 3 failovers within the period here is within 300 seconds, which is okay. So we are going to say show pipe compare. So I'm going to do the pipe compare. So these are the values that we just added. So I'm going to hit commit and quit. Okay. So that's going to apply, and then we are going to do the power cycle. Okay. So I can come here and say request chassis cluster. Request system reboot. Okay. So the reboot is good. So we need to check what will be the impact because we did not do it on the first one. So I'm going to just hit enter. So the reboot kicks in, and then we see, is there any impact? There's no impact. Okay. And of course, if you are using hardware, it could be what you experience might be different. For hardware, this is virtualized environment. Maybe you get better performance there, or okay. So here, if we come here again, it should tell us it's now on it's now lost. Okay, but see what is going on here now. Okay, you see what is going on now. Instead of transitioning directly to primary, what is it doing? It's now in a hold down state. Okay, it's in a hold down state, but it's not necessarily affecting the traffic. Okay, it's not necessarily affecting the traffic. It means the traffic has moved down to the secondary, right? But its state is what? Is in a hold down state. What this is actually doing is, just like we said, if there's a flap on the other end and maybe the port went down and it came back up, and then you're trying to fail over the traffic back to the primary, it's going to say no. Okay, because that port is flapping. So it's just a way of, it's just like we said, it's a dampening mechanism just to ensure there's much more stability between both devices. You don't have traffic moving between both devices even within seconds, almost within the same time. Okay, so it's a dampening mechanism that keeps the system at a steady state for a particular period, depending on what is configured. So if we leave it this way, after some time, it's going to see. So it transition from primary preempt hold to secondary hold, then before it gets to secondary. I think I explained this part in the last session in part 4 on how the secondary transition from secondary to primary, and then also from primary to secondary, where it moves from the primary to primary hold, then from primary hold it goes to secondary hold, then before it becomes secondary. So here too we are saying the same thing. It's moving from the primary preempt hold, right, to the secondary hold, then before it eventually becomes secondary. So while that is running, we're also going to wait for this device to boot back up. Okay, so I might just need to pause a little bit again. So now it has transitioned from the secondary hold state to secondary, right? Is this supposed to go to secondary or primary? Okay, I think this device is back up. I think that should be the reason. Let's see. CLI show chassis cluster status. So it's so here's secondary here, and oh, I think it's primary. I think I'm probably looking at it in the wrong way, but it's secondary here. So this actually should be primary. Yeah, exactly. So it's primary here because it's, so let's look at the stages, how it transitioned again. So it started from the primary hold states, and then it moved to secondary hold, right? And then from secondary hold it moved to secondary. Okay, and then it transitioned back to primary. Okay, and this node 0 is secondary. Well, let's do the show chassis again. So he's going to stay as secondary, and then if we give it some time, because preempt is enabled, we expect node 0 to take back this row, right? Yeah, so it's going to take back the row from secondary back to primary, while this transition back to primary. So it could take a lot of time. It's going to take a lot of time for the transition to happen. So I'm just going to be pausing the videos as the stages changes, just to save time. Okay, guys, welcome back. I have to be honest. I had what I did behind the scene was that I had to do a second reboot because what was being displayed was not too clear. Now, what happened is this: we did a reboot of the primary, right? So here's what happens. So this is let me grab my pen. So this is node 0, and this is node 1. Okay. Now, the moment we rebooted node 0, it transitioned to the state was lost, right? Because when you say show chassis cluster status, it will report that node 0 was lost. Now, it moves from lost. When it comes back up, it moves from lost to hold. Then from hold, it goes to secondary. Okay? Right? Now, in secondary level, that's where they, of course, compare their priority. Don't forget, we are referring to redundancy group 1 here. That's our use case. So it moves from lost to hold, then from hold it goes to secondary, and then if the priority, of course, there's preempt, right? If there's preempt and its own priority is higher, then it's going to transition back to primary. Now, at the point where it was lost, this became primary. Okay? Now, it's going to remain there as primary up to this stage, right? So here will be primary, this comes up and gets to the secondary, this stage where it's secondary. When it's secondary, the priority you see there is usually set to 0. Okay? Now, during the election, and of course, they compare their priority, they say there's preempt. This device is going to say, well, I have a higher priority than you, and preempt is enabled. He's going to move to primary. At that point, node 1 will move to primary preempt hold. Okay? Then from primary preempt hold, it goes to secondary hold. Then before it eventually becomes secondary. So that is actually the transition stage. Now, the reason why you are seeing this is because of the delay we set. I don't even remember the value that we set, but I know there's a delay timer. Okay. Now, instead of moving from primary directly to second, normally it should move from primary to secondary hold. Okay. But because there's a delay timer which we configured, it's going to say, well, okay, I know I need to leave, but there's a delay timer that is set. Right? I think we set 60 seconds. I can't even remember. I'll check the configuration again. So we really need to take note of this transition stage, right? That, oh, this device was power cycled. This is how it goes. It's initially it's lost, then it goes to hold, to secondary, and then takes back his role as the primary. Then the device that was originally primary goes to primary preempt hold, then goes to secondary hold, then before going to the secondary. Now, there's a lot of timers, there's a lot of moving balls, so sometimes it could really be confusing. Now, for redundancy group 0, we know there's no preempt. So what usually happens is for node 0, which is this, and this is your node 1, right? So it's going to go from lost, right, to hold, and then to secondary. Okay? Then for this device, this is primary, and we continue to be primary because there's no preempt in redundancy group 0. Okay. Now at the secondary here, the value will go back to 200, and here will remain as 100. Okay. But because there's no preempt, this will continue as secondary while the primary still. So there's no failover for redundancy group 0 when there's a reload, and even when, and of course there's no preempt, just like we have said. Okay. Yeah. So I believe, so the other thing we needed to test is so the other thing we needed to test is the delay limit, right? We're going to do that in the next video because we're almost out of time here. We'll test the delay limit and the delay period. Okay. And of course, even the delay timer is still going to apply. Okay. So what we'll do is we'll enable interface monitoring, and then we'll try to manually shut down the port that will cause 3 failovers within 5 minutes. And we're going to see that, oh, traffic is going to be moving back and forth between the device, but once it hits the limit which is within the threshold, okay, so we're going to set here as 3, and we're going to set here as maybe we can set it as 300 seconds. So we're going to see once this limit is reached, it's going to disable preempt until you do a manual reset the timers again. Okay, and then then additionally, what we'll test in the next video is that we'll check when will a device go into the ineligible state, and also the disabled state. Okay, yeah, so here we'll do interface monitoring. So we're going to do interface monitoring, the disabled state. Then we also have the IP monitoring. So we still have a lot that we need to talk about. Okay, we're going to be pinging for the one link. We're going to do some additional enhancement where you monitor both the interfaces, but you're also monitoring IPs on the internet. And you say, okay, if there's a failure on the IP on the primary, we want it to fail over to the secondary. We're going to look at look in depth of what is actually happening, how the devices is actually carrying out those pings, where is the source IP, where is the source MAC addresses for both the primary and the secondary. So we need to really understand those details. So that this will cover what we'll discuss in the next session. So I see you then. Now, if you like this video, please subscribe and share, like, and yeah, see you in the next video. Thank you.